Have you ever observed this? When you open Binance APIs in the browser, go to the developer tools and network tab and refresh the page again and open the API, go to the response headers and look at this header that is content encoding gzip. Do you know what it means? It means that the data is compressed on the server before sending it to the browser. So in this video, let's look at how to achieve this compression. But before we look at the code, I want to take some time explaining why we have to do it. So if you take any cloud service provider like AWS or Heroku or even Google Cloud, data is one of the most overlooked aspect of the project, especially if you're not working on a project that involves large data sets. So people just assume that the data is free, but it's not. Let's just talk about AWS because that's what I'm mostly used to working with. So if you look at AWS servers and EC2, if you look at EC2 droplets, you can see on the screen that only the inbound data is free. So the data that you download to the server is free, but all the outbound traffic, you have to pay for it. So only the first GB of data is free, but after that, you're paying at 9 cents per every gigabyte. So 9 cents per every gigabyte might not sound much, but we're talking about almost, let's round it off to 10 cents, right? So you're talking about $1 for every 10 gigabytes of data. And it might sound like a lot, but it's not, especially if you have like hundreds of users and your whole project, if you're working on a data-centric project where you're serving large data sets between your server and the client, then you would use up this data quite quickly. So it's always a good practice, especially if you're dealing with large data sets, to implement some kind of compression so that you're minimizing the data footprint. And it's not just with EC2. If you look at Lambda functions or API gateways, that is still the case. So any of the inbound data is free, but outbound data, it's free. The outbound data is free if the traffic is routed to one of the other AWS service like EC2 or Lambda function. But if it's not an AWS service, then again you have to pay at the same rate, 9 cents per gigabyte. Again, this rate depends on the region, but roughly, it's on the same ballpark, around 9 cents per gigabyte. So what I'm trying to tell you is data is not free, especially if you are dealing with large data sets in your project. So it's always a good practice to implement some kind of compression to reduce the data cost incurred in the project. So first I'm going to create a simple Node.js project with the command npm init:\y. That's it. Then I'm going to install two packages. The first one is Express. Then I'm going to install another package called nodemon so that whenever I make a code change, the project is restarted automatically. -d flag installs it as a dev dependency. Then I'm going to go to package.json and set the type to module because I'm going to use ES6 syntax. And I'm going to create a script called dev where I'm going to watch all the files and restart the project every time a code is changed. I'm going to create a new file called server.js and then start the project with the command npm run dev. That's it. First, I'm going to create a simple Express server by importing the Express module. Then I'm going to create the app and I'm going to default the port to 3000. And then I'm going to use the middleware express.json and then listen to the port 3000. So I'm just creating a simple Express server. Then I'm going to create a file called data.js which has a sample JSON response. I'm going to use it in the code to do the compression and send it to the client. All right. Then I'm going to import the data in server.js and then I'm going to create a simple route that just sends the data as response. Let's save it. And when you go to the browser and open this URL, you will see the sample JSON on the browser. Then let's create a new file called compress.js, which is where we're going to have the functions to achieve the compression. I'm going to use a package called ZLIB, which we're going to use for compression. This is native to Node.js, so you don't have to install any additional packages for this. Then I'm going to create a function called compress, and inside this function we're going to return a promise because ZLIB by default it doesn't give you promisified functions. So inside this promise we're going to call ZLIB.gzip. So ZLIB is the library, gzip is the compression protocol, and this function takes in 3 parameters. First is the data, then it's going to take options, which is the level of compression. We'll talk about this option later in the video. And then we're going to pass a callback function that is going to resolve with the compressed data or reject if there is an error. That's it. Let's save it. Then I'm going to create a controller with this function and then export this controller as the default. Let's save it and go back to the server.js file. In the server.js file, first I'm going to import the compress.js file that we just created. Then I'm going to create an additional route called /compress, which is where we're going to handle the compression logic. So I'm creating 2 different routes, one without compression and one with compression. All right. And this is going to be an async function because again, we need to compress the data. So I'll put the async keyword in the callback function. And then I'm going to create a try catch block. And wherever there's an error, I'm going to send an internal server error response. And otherwise, first we're going to stringify the data, the JSON sample JSON data that we created earlier. Again, one thing to keep in mind is the compression function can only take in stringified data. So it's important that you stringify the data before you send it for compression. And then we're going to create compressed data by using the zlib.compress function and passing the stringified data. And it's an async function, so we'll just await for that. And then we're going to send this data to the browser. All right, let's save it. And if you go back to the browser and open this URL, you will see that the data is in the form of a buffer and yeah, it's compressed. Now, in order to decompress the data, we don't need to write any extra code. All we have to do is pass the header content encoding as gzip and content type as application JSON. And when you apply these 2 headers, the browser can automatically detect that this is compressed data, and it automatically decompresses the data and renders it on the browser. So let's see that. When I save it and go back to the browser and run it, awesome. So you can see that the data is rendering properly. And if you go to the network tab and open this API, under the response header, you can see the content encoding as gzip. So this is compressed data. Unfortunately, the browser doesn't tell you what degree of compression is achieved. So let's try to find out using Thunderclient. Now, when I open this URL in the browser without compression, it gives me the content length as 237751. But when I call the compress API and send it, it's the same data, right? We are compressing the same data in both the routes. You can see the content length is 20538. So let's do the math, right? 237751 divided by 20538, that gives you 11.57. So we have achieved 11x compression, which is significant, right? Think about it. Let's round it off to 10x, right? So if you were to send 1 terabyte of data without compression, that would drop down to 100 gigabytes with compression. Or if you're using 100 gigabytes without compression, that drops to just 10 gigabytes. So that's a 10-fold or 11-fold compression, which is significant. So let's do the math, right? So 10x compression, you would also save 10x on the data cost, right? So wherever you're paying $100, you would now pay $10. So that's a significant reduction. One thing that you'd notice though is the status port is not 200 for the compressed API. And the reason that is the case is because browser caches this response, and if it doesn't change in the subsequent calling, it flags it as 304. That means the data hasn't changed from the previous execution or previous trigger. So to fix that, you can add some additional headers in the code to prevent the response from being cached, and that should resolve this issue. Now, after adding these headers, if you go back to the page and refresh, you can see the status code is now 200, so it looks good. Again, you don't need to add these headers. Again, if the data doesn't change and the browser is caching, there's nothing wrong with it. So I just wanted to demonstrate how you can get status code 200, but you can remove these headers. Finally, I want to talk about this level option that we passed in the compressed function. So this parameter indicates the degree of compression that we want. Smaller the value, smaller the compression, but it's also going to be faster. Higher the value, then a higher degree of compression, but it's also going to be slower because again, you need to allocate more CPU cycles to achieve a higher degree of compression. And the value lies somewhere between 1 and 9. And if you don't want to hardcode the value, you can use constant from ZLIB. So if you want to use the minimum value, you can use zlib.constants.z min level. So that passes the minimum value. And if you want the maximum value, you can use z max level. And if you want to use the default value, you can just use default level. So again, you can either pass the numbers directly or you can pass these constants so that even if the package gets upgraded, you are future-proofing your code. Let's delete these. Now, before I wrap up the video, I want to do one last test. I want to see how long it takes to run different compression levels and what is the degree of compression achieved with different levels. So let's run one last test before we wrap up the video. So first I'm going to create another function called compress metrics. It's the same function as compress, except that it takes another parameter called level, and we are going to pass it as an parameter instead of hard coding the value. And then I'm going to export this in the controller. Again, the reason I'm creating a separate function is when I deploy the code to GitHub, you have access to both the versions. Alright. Now go back to the server file. Here I'm going to create a new function to calculate these metrics. So I'm going to create a function called calculate compression metrics. And first, as always, I'll just create a try-catch block because it's an async function. And first, as always, I'm going to stringify the data, and then I'm going to create different levels. So these are all the possible values from 1 to 9. And I want to see, like I said, the degree of compression and the time it takes to compress. All right. Then I'm going to create a function called compression times. And first, I'm going to get the start time using process.hr time. So this process.hr time gives you the exact nanosecond value. So it's more accurate. All right. So we use HR time to calculate precise time or time duration. All right. Then I'm going to do the compression and then get the end time. So this tells me exactly how long it took to do the compression. All right. And then based on these values, I'm going to calculate a bunch of metrics, which is compression time and compression ratio, and then return the result. All right. And we're going to run this function for each level so that we get the values, the compression time and compression ratio for each level. So let's do that. We just use await promise.all and run it for each level. And then I'm going to console log the value by using console.table. So console.table prints it in a row and column format, so it's more readable. All right. And I'm already invoking the function here. So let's just save it and you should see the results down below. So I'll just bring the console slightly higher and let's save this. And yeah, you can see the table right below. You can see that as the compression level increases, the time it takes to do the compression is also increasing, and the compression ratio, you can see that a higher degree of compression is achieved. But here is the thing, right? So with just level 1, you're already achieving 11x compression, and with level 2, it's marginally better, but it's not drastically better, right? So you're not achieving like 11x compression from level 1 to level 2. So I would say, if level 1 is already doing the work for you, if it's already achieving like a good degree of compression, then maybe you don't have to go all the way to level 9, which takes longer, and it's going to clog the queue, and it could be unnecessary is what I'm saying. So depending on these values, maybe you can decide how much is too much and how little is too little. So if a smaller level is already doing the job for you, you may not opt for a higher level is all I'm saying. All right. And these numbers can also depend on the data that you're compressing. So again, the way the compression works is, if you have a repeatable pattern in the data that you're compressing, then a higher degree of compression can be achieved. But if the data that you're compressing itself is quite, doesn't have a lot of repeatable patterns, then the data may not be compressible to a great extent. So these numbers that you're seeing is dependent on the data that you're compressing as well. So you may not see the same numbers when you're trying to compress a different kind of data is what I'm saying. All right. So play around with these settings and figure out what best fits your project and then stick with those values. All right. To demonstrate my point, I created a new file called data2.js, and here I'm trying to compress this data. As you can see, it's just alphabet from A to Z and numbers from 1 to 0, sorry. You can see there is not even a single letter or number that is repeating in the string. So this data can be considered as not too compressible, and it's obvious in the results that you get. So you can see the compression ratio that we achieved is not that much, right? So yeah, what I'm trying to say is that the compression ratio that you see is totally dependent on the data that you're compressing. So play with these values and figure out what best fits your project. Alright. Before I wrap up the video, I want to show you that it's not just Binance that does the compression. If I open a Bybit API, and if you go to the response headers, you can see it has content encoding gzip. And even when I open Kucoin API and go to the response headers, you can see content encoding gzip. So in my opinion, most of these exchanges that offer data, they do this compression to save on data cost. That's about it. I just wanted to quickly explain about compression, how it works, and when you should use it. Again, leave your thoughts and suggestions in the comment section, and I'll talk to you in the next one. Bye.